Today, I needed to water my plants. They had some problems with gnats, so I topped off the soil layer with a layer of bird sand, which did the trick in case any of you have the same issues. Anyways, looking at the sand and being reminded of books about the desert I read as a child, I started wondering, are there more atoms in a single grain of sand than there are grains of sand on Earth? To the despair of my remaining plants, this was an interesting enough question that I promptly needed answering. So I grabbed a piece of paper and a pen, determined to solve the problem myself and not just look it up online. By the way, this is a microphone thingy to reduce pops. This isn't, I'm not talking into my cum sock. As soon as I sat down, it dawned on me that estimating the number of grains would probably be quite the undertaking. So, of course, I did the reasonable thing, starting with the number of atoms, hoping that the solution to the former would magically reveal itself to me in the meantime. The first thing I needed were some sensible assumptions about sand. Sand, depending on its origin, can be composed of many different molecules. The most prevalent one should be quartz, the crystalline form of silicon dioxide. Given that, as a first-order approximation, let's just claim that all sand is pure quartz and hope that we can outrun geologists before they bash our heads in with some fancy rocks. To further gain their hatred, let's also assume all grains of sand are of the same size and perfectly spherical, with a radius of around 0.125 millimeters. The radius I chose somewhat arbitrarily, looking at this image on the Wikipedia article for sand, choosing the type of sand that was labeled dune and counting grains in one row and dividing the side length by that number times 2. In quartz, the silicon and oxygen arrange in SiO4 tetrahedrons, sharing pairs of oxygen atoms with their neighbors. One can build a unit cell consisting of 3 silicon and 6 oxygen as such. These unit cells can then be considered the basic building blocks of the crystal, and they can tile the space in a rather straightforward manner. The side length and angles of the unit cell are well-known quantities, and using the formula for a parallelepiped, its volume can easily be calculated. The number of atoms per unit cell is 9, so dividing the volume of a grain of sand by the volume of a unit cell times 9 gives us the total number of atoms per grain of sand. Here, the volume of a grain of sand is calculated using the spherical grain assumption. The total number turns out to be 6.52 times 10 to the power of 17, which feels about right, but I have to admit I'm a bit rusty in solid-state physics, so let's cross-check those results by calculating the number of atoms another way. Quartz has a measured density of 2.65 grams per centimeter cubed. Multiply that by the volume of a grain of sand to obtain its mass. This we can divide by the mass of a silicon dioxide molecule, which is 2 times the mass of an oxygen atom plus the mass of a silicon atom, or roughly 60 daltons. Because silicon dioxide consists of 3 atoms, we need to multiply the result by 3 to obtain our result of 6.53 times 10 to the power of 17, meaning we have a very good match between our results, which gives me some confidence that we aren't too wrong. Okay. Now it's time for the part that I wasn't looking forward to, guesstimating the amount of sand grains on Earth. If you want to be charitable, you could call this a Fermi problem, or you could call this pulling out numbers out of your ass. We'll see. Let's start with a lower bound. The biggest desert on Earth is the Sahara, at least if you aren't pedantic about it. It spans an area of roughly 9.2 million square kilometers, so let's start here. The really sandy parts of a desert, you know, the ones you see in an establishing shot of a movie taking place in the Middle East with the wobbly air effect laid on top, are called ergs. Big dunes, hella sand, you know the deal. And looking at this image of the Sahara, I'd say like 20% fit that description. Remember, lower bound. There's probably more sand in the more rocky parts of the Sahara, and there are ergs outside the Sahara, like the Rub al-Khali. If the results are within a number of magnitude or 2, to each other, we can further refine the estimation. So the ergs are occasionally really tall in terms of sand height, with dunes reaching up to 250 meters, and sometimes they are only a few inches deep. So let's choose some value between and say 30 meters of sand on average. With that, the volume of sand can be calculated as the area of the Sahara times 20% to limit ourselves to the ergs alone, times the depth of 30 meters. This gives us an insane amount of 5.5 times 10 to the power of 13 meters cubed of sand. This is, for all intents and purposes, a lower bound. We neglected all other deserts, dunes and beaches on the planet, especially places like the Namib, Rub al Khalil or the Gobi Desert would contribute substantially. And I swear, I didn't just mention them so that I can use this as an excuse to show you an image of this fucked up little guy. That's a Gobi Jabor and I'm ready to kill in its name. Okay, focus. With the volume of sand in meters, it is now time to convert this into grains of sand. Simply dividing by the volume of a grain might sound reasonable, but this would mean that the grains would arrange perfectly without any gaps of air in between, which just isn't the case. And in our assumption of spherical sand, this wouldn't even be possible. Try it yourself. Grab a bunch of equally large balls, table tennis balls or marbles or whatever, and try to pack them as closely as possible. The highest density you will manage to pack will be such that 74% of the space is occupied by the spheres. Figuring out why 74% mathematically is a nice problem to solve for yourself if you want a challenge. Start by realizing the unit cell structure of the closest packing looks like this and expand the spheres drawn until they touch. That is the ideal packing of spheres. But in the case of a random arrangement, as one might expect for the grains of sand in a desert, the packing density is probably more on the range of 63%. So let's divide the total sand volume by the grain volume and multiply by the packing density to arrive at a total number of grains of 4.3 times 10 to the power of 24. This is substantially larger than the number of atoms, even for this lower bound. So we can be fairly certain that there are, in fact, more grains of sand on Earth than atoms in a grain of sand. Case closed, right? Well, we made a lot of assumptions, of course, the radius of a grain of sand being one which I think might have a huge impact, as with it the number of atoms per grain scale to the third power and the numbers of grains scale inversely by the third power, meaning that the ratio between the two depends on the radius to the sixth power. But the average radius would be around 2 millimeters to get the atoms per grain to be larger. And looking at the type of sand I have laying around at home, I would say this is pretty unrealistic. On top of that, even if that were the case, we only considered a small amount of the total sand available on Earth. If the total amount in terms of cubic meters was an order of magnitude or even two larger, I wouldn't be surprised. So to truly have more atoms than grains, the radius would probably need to be pebble-sized. With that argument, I feel more confident in my answer, but just in case, maybe I should compare against what other people have written about us online. I clearly remember those "are there more grains of sand than stars in the observable universe" type questions that were posed in science books for elementary schoolers. So there have to be some calculations online about the topic. So let's just punch that into Google and see what we get. Oh hey, Geeks for Geeks has an answer. I love that website. They have some nice tutorials on the basic of Julia. Surely they know what they are talking about, right? Yeah, it says right here. It's even highlighted. 7.5 sextillion, 75 followed by 17 zeros to 21 sextillion. That's way off from my estimation by quite a few orders of magnitude. 75 followed by 17 zeros, that's 7.5 times 10 to the power of 18. So there are 6 orders of magnitude between my estimation and theirs. That's like asking how many people live in Germany and one person says 80 million and the other person says 80. Or if I'm the one overshooting, in my estimation, it's like asking how many fish live in the ocean, and one person says 3.5 trillion, citation needed, and the other person says 3.5 quintillion. Wait a minute. 10 to the power of 18 is a quintillion, but it says right here in the little blurb 7.5 sextillion, 75 followed by 17 zeros. That's two different numbers. I didn't notice at first because who even cares about the names of numbers above a trillion? But that's just blatantly wrong. A sextillion is 10 to the power of 21, a number that is coincidentally also appearing right here. But let's not jump to conclusions. Instead, let's read the article. Maybe the editor just made an honest mistake whilst trying to make large numbers somewhat comprehensible and fumbled in the row on the list of large numbers Wikipedia article. Okay, let's read the article and... that's the entire thing. This part up here is just filler, then according to the latest studies, the Earth contains and the numbers from before. Of course, with all crediting the studies. Classic. You know, I'm always a little annoyed by pop science articles that reference a study and then don't properly credit it. Those researchers have probably invested quite some time into their work just for someone to take their results without any acknowledgement.
Foreshadowing is a narrative device in which
Further, the article states, these estimates rely on assumptions about average sand grain size, sand depth in different areas, and total sand covered area. See, that's the part I'm actually after. How did the studies arrive at their number? From the article, we can infer that there have to be at least two different studies, and the results are rather close to one another, a factor around 3. For such a question with so many variables, that is impressively close. So I'd really like to know how they arrived at those values. That could probably help me understand where the mistake in my calculation must have been. If only I knew those studies. What do you know that I don't, Raoul? Okay, carrying on. This part is just another filler sentence, and this seems to be an ad written out in the text itself. Okay, so we have maybe 2 sentences of actual information. Not a lot to go off of, but this article is very recent, published in February of 2024. And I have the sneaking suspicion that these 2 sentences weren't based on original research. Now, I don't want to indict Raoul here, but mistaking sextillion and quintillion is rather unique. So let's just search this phrase and... Oh, here's another article or blog post on the website Medium from April of 2023. Now, Medium is one of those weird websites whose concept I don't fully understand, but I think you can just write your own stuff on there, like you would back in the day on Blogger. So it is basically a self-published article, but scrolling down a bit, just below the generic stock image of a beach, there's our weird phrase again. According to scientists, our planet has 7.5 sextillion, in parentheses, 75 plus 17 zeros, grains of sand. It even comes with some funny quips, including beaches, desert, and sandboxes. What a knee slapper! I'd be willing to bet the Geeks for Geeks article is entirely based on this one, just rephrasing it a bit and omitting the part about the numbers of stars. I don't know where the 21 sextillion number is coming from. Maybe there was some intermediate article I've missed, or maybe Raoul just employed some creative liberties to make it less obvious where he got his information from, or maybe there is genuinely a second article he found that he also based his results on. I really don't know. But let's return to the Medium post. This entire thing is weird. First, the article claims that the number of sand grains it gives is an estimation from the entire planet. Remember the hilarious joke from before? Of course you do, that was 6 sentences ago. It states that every reservoir of sand is considered, only for the article to perform a fucking 180 2 sentences later, saying that the estimation is based on beaches only. Now, I'm not an expert at sand, but I'd say all beaches collectively are probably a bit smaller than all the deserts. But what do I know? Oh, and the weirdness is not over yet. It explicitly uses this article by Fraser Crane as a reference, but then doesn't use any of the values given in the article. The Fraser Crane article is clearly stating that he just tries to estimate the numbers of grains on all the Earth's beaches. Moreover, he himself makes abundantly clear that he is using an estimation provided by another person, Dr. Jason Marshall, aka the Math Dude. The numbers he provides, about 5.5 sextillion, and this time actually sextillion for beaches only, are much more in line with that what I would predict, which is nice to see. And I can't express how silly this all feels. The Medium article gives a number which it claims for the entire planet, links to another article saying that the beaches alone are either on the same order of magnitude or outweigh the Medium article's estimation by a factor of 1000, depending on how you want to interpret the sentence. Only for the Medium article to then say, oh, actually, I was talking about the beaches also. I'm losing my mind a bit. However, I still want to find the actual studies, or at this point maybe one study, singular, as the Medium article uses the phrase researchers, not recent studies, plural. I guess we'll have to see. The original article by the Math Dude is down, but you can still find the website on the Wayback Machine. It and the video by Fraser Crane are actually really nice, but sadly, they aren't relevant to the hunt for those elusive studies, plural, question mark? So let's leave this island of sanity behind and dive back into the deep ocean of internet slop. See how I created a visual metaphor harking back to the theme of beaches? I'm such a gifted writer. Searching the phrases from the Medium post, 7.5 sextillion, parentheses, 75 plus 17 zeros, of grains of sand, I found another article, this time published by the daily newspaper The Oklahoman, containing the same phrase. Scientists estimate that Earth contains 7.5 sextillion sand grains. That is 75 followed by 17 zeros. Now, there isn't a date of publishing on the article itself, but if the URL is to be believed, this dates back to February of 2019. I have to tell you, this article is hilarious. There are more stars in the universe than all the grains of sand in all the beaches, deserts, and sandboxes on Earth. Man, what a knee slapper. Anyways, the Oklahoman also doesn't provide any sources. Just claiming some unnamed scientists have figured it out and leaves it as that. Great. At this point, I felt the search for the sextillion versus quintillion phrase had run dry. So instead I searched for 7.5 quintillion grains of sand, and without really expecting it, I found another article, this time by NPR. Now, in retrospect, I felt a little silly because this article was there the entire time. Just below the Geeks for Geeks article, I just didn't notice it because Google decided to promote this sentence as the one thing I should command all my attention to. The NPR article from September of 2012 finally gives me some more information. The number, 7.5 quintillion grains of sand, was based on a, at the time, newly released book written by one David Blattner called Spectrums. As per the NPR article, David got this number from a study performed by a group of researchers based in Hawaii, being versed in all things beachy. What a weird thing to say. Doesn't matter, there's a link to what I suppose to be the study. And it's that. Of course it is. Site could not be reached, connection to the server, mail.npr.org could not be established. But there's still the book, which luckily is available online. Quickly skimming through it, I found the part where he talks about the number of sand grains. To quote, University of Hawaii researchers who should know estimate Earth has about 7.5 billion in parentheses 7.5 times 10 to the 18 grains of sand. I'm sorry, that has nothing to do with the actual question at hand, but it's now 2 for 2 on the uncalled for offhand comments list? Is there a firmly held belief that Hawaiian people are some sort of fucking sand wizard or something? Anyways, no source again. This time, I think it's even more insulting. this is a book written, published and sold only for it not to at least include a name or DOI or anything. He profited off of the work of others directly, only for their work to go uncredited. That's foul behavior in my opinion. So of course he got a TEDx talk. H-Bomber guy truly is a prophet. As much as I have just shit on David, I have to acknowledge that the information about the researchers being based in Hawaii might have just helped me find the original source, however. Searching for 7.5 quintillion grains of sand, University of Hawaii, I found this article, finally giving me a name, Howard McAllister, on some engineering consultant website. Sure. Notice though, one guy, no longer a research team, but searching up his name, I came across a Stack Exchange thread mentioning his estimation, and they finally provided a link to his study on the topic. Guys, we did it. I know the road wasn't easy. We have lost some good men along the way, but finally, after the trials and tribulations, we are finally here.
Link is dead.
Okay, sure, but this time we have an actual link, and it's the University of Hawaii. The Wayback Machine certainly has a backup. It might load for 2 minutes, but here we are, and that's it? That's the entire thing. It's a rough estimation for the number of sand grains on, once again, all of Earth's beaches, not all of the grains of sand on the planet. And the whole estimation was made as an example on how to perform a back-of-the-envelope calculation to solve a Fermi problem. All the way back in February of 1996 by, mind you, a professor in astrophysics. So, whilst probably quite a smart guy, not an expert in the field by any means. Not that it would even fucking matter, because this isn't a study. This isn't academic research. This is just an order of magnitude approximation performed as an example for order of magnitude approximations. The whole thing was just used as a showcase for, at least how I understand it, a potential use case for the problem-solving software SureMath. He seems to have been quite fond of the product, even quoting Machiavelli in the website.
Join the Get IMAC campaign now.
This is truly peak.com bubble stuff. It's kind of endearing, just some professor in his later years wanting to improve the teaching process through this new and exciting wave of widely distributed home computing. Reading through his solution, I really quite like his approach to the problem, but it's a problem that has nothing to do with anything we actually care about. Sorry to say that, Howard. So, through the years, out of some example for how to use a piece of software became a group of researchers, became multiple studies, up to present day, almost 30 years later, where basically every word in this stupid fucking Geeks for Geeks article is wrong. This is not the latest, it's 2 years older than I am. Those aren't studies, plural, nor studies at all. It's not on Earth, just the beaches. It's not 7.5 sextillion, and I still don't know where the 21 sextillion even comes from. Like a giant pop science version of the Ouroboros, probably 100 of pop science articles regurgitate the same factoid of information as if it were based on actual research. No wonder none of them ever gave any credit to the study they were all supposedly referencing. There never has been any to begin with. This kind of journalism with the biggest fucking quotation marks you can imagine pisses me off so much, and is no better than those endless seas of celebrity drama articles written by either AI or the world's most miserable authors, a trap to make you click only to realize too late that there is no information to be gained in the article, but it's too late because you already clicked and needed to scroll through 20 ad banners and 4 auto-playing videos just to find that there is nothing of value left. It's like getting tricked into ordering a Big Mac with a fucking BetterHelp ad hidden in the patty. where does this leave us? Stuff written on the internet is often untrue, maliciously so. That is nothing new, and if it is to you, I need your credit card information for some unrelated reasons. Don't worry about it. But other than that, a lot of stuff also just gets embellished over the time. From a rough estimation 30 years ago to peer-reviewed, hot-off-the-press research in an attempt by different sides to top one another in grabbing attention. There's a banality to it, the inevitability of a system designed around profiting off of grabbing as many seconds of your limited free time. It's tragic that the one avenue a lot of people have towards accessing what is happening in the world of science, a pop scientific perspective, is flooded by just blatantly wrong information. I don't want to come across as some elitist ivory tower goober who wants science to only be accessible for scientists. The average person is way more interested in what is going on in the world of science than one might think. Otherwise, such articles would not be profitable. Online resources are, for most people, the easiest and most digestible way to keep up with what is happening in the world of science. And there are good, really good articles, blogs, videos, whatever out there. But how is a layperson supposed to differentiate? To an extent, I am a cog. However small in this too. I know you make one YouTube video once and can't stop talking about yourself afterwards, but waking up to the equivalent of a small city having watched your shit is somewhat of an odd feeling, so indulge me in my ramblings. I don't have any obligation to make my content engaging from a monetary standpoint, but even still, writing scripts, I can feel the push and pull between making the videos exciting and keeping them firmly grounded in reality. Sorry mate, I really do appreciate your excitement, but fractals don't explain quantum entanglement, and you won't catch me dead making such claims to dupe people with the aim of success through sensationalism. You are still watching this video, so I have succeeded in keeping your attention. Hey, great! My hope is you can leave this video with having gained some new insights. But in the pursuit of this, I had to make certain decisions on what information to include and which to omit. Details I found interesting, which nonetheless would have resulted in bloat. On the other hand, on topics I am not an expert on, I had to rely on the simplified explanations of others, trusting in the accuracy of their claims, just as you might be entrusting me. Not even a day after I released my last video, some person correctly pointed out a mistake I made. I fumbled my explanations regarding fixed points of a system, and they corrected me in a genuinely very nice manner, which sucked because I should have known better. Dynamic systems are much closer to my field of expertise than knowing what an erg is. I looked that up the same way you would, just reading the Wikipedia article. I'd argue, in the framework of this video topic, this is enough. But were this video purely about the amount of sand on Earth, I would reason my knowledge is subpar, and I would also start regurgitating stuff I don't really know about deserts. I have recently watched Oliver Luck's video on the extinction of dinosaurs for probably the 10th time now. He dives deep into the world of science communication to an extent where I'm genuinely unsure if he hasn't suffered from long-term effects now, with him having to wade through the topic for what must have been grueling months of research. If you are interested in the topic, even if you aren't, I urge you to watch the video, because he goes into way more detail than I could hear. So, finally, to wrap things up, there are more grains of sand on Earth than atoms in a grain of sand. And never trust anything you see on the internet. Also, fuck you Geeks for Geeks, and fuck you Medium. I still don't understand who your target audience is even supposed to be. Goodbye.